So my name is Bryan. My background is that I'm a Bitcoin core contributor. I have a software development background. Lately I've been doing a bunch of contracting that's like everything from code review to building new things. I was previously at LedgerX, where I developed a system to securely store Bitcoin for the first CFTC-regulated Bitcoin options exchange, the first federally regulated Bitcoin exchange. You might know me because I write transcripts very quickly. I also have some biotech projects. So let's get started. So let's start with what security is. Security is generally this game where you have a defender and an adversary, and the adversary is going to attack the defender. In web applications, it's a bit different because you are exposed to the entire internet. And not only that, but the stack of software that you have to protect and defend is enormous. So it's asymmetric in the sense that the attackers just have to wait for you to get one thing wrong, and the defender has to get everything absolutely right, which is very difficult. Adding Bitcoin to this is dangerous because it gets even more intense because now there's Bitcoin that can be stolen. There's a financial incentive for people to attack sites now, more than there previously was. So in particular, it's a huge surface area, a lot of software to protect. Here's your cheat sheet for how to hack websites real quick. We're actually going to break something in this session, so let's break Bitcoin. So as a very trivial example, I'd like to talk about a file inclusion vulnerability and what that looks like. So imagine, without knowing the source code that you see at the bottom of the screen, that you come across a URL like in the middle of the screen. And what you should think, without knowing anything about security or web applications, is you should look at this URL and go, what is going on here? You can break it apart into a few components. You have domain, apartmentportal.com. Then you have some file, apartment photo, with some file extension. And then you have like this other file name in there. But that's actually not the file that the website is that the web browser is requesting, but it does specify which file we want the web server to return. And so in the early days of the internet, this was actually quite common to have a vulnerability like this where you could just change that value to anything you want. Like at first you should think, well, if there's an image 50,341, maybe there's an image 50,342, and then change it. And if that works, well, what about using the same file name, like apartment photo? Does that work? And often the answer used to be yes. And so the way that this works, the way that the vulnerability works under the hood is in the source code example on the bottom of the screen. And essentially what happens is that it takes user input and then opens up the file directly without sanitizing it or having a whitelist or anything. And that's really bad because you could just open up anything you want on the server. Another really interesting one that I like is source code disclosure through .git. Depending on how you misconfigure your web server, it is possible to expose source code and your source code repository in a dot directory, a hidden dot directory that you forgot to remove or something. Usually if you follow like online tutorials for how to do web application development these days, this actually won't happen. This isn't the default, but it certainly has been known to happen. And if the web server has indexes enabled, you'll see something like on the left of the screen. And if it doesn't, you can still guess file names because Git always uses the same file names. So then you can download the whole repository and view the source code of the website that you're attacking. So I want to tell a brief story. It was 2002. I was 12 years old. I was obsessed with this website that I made that had 1,000 users, and for a 12-year-old, that was a really big deal. It was about anime, a topic I knew absolutely nothing about. And I was in school, and I used to update the website through an SSH Java applet. But then the school blocked Java applets because, games. Then I used to use FTP, but then they blocked, downloading software and installing software on the school computers. So I became obsessed with this, and I was trying to think one day, how would I do this if I wanted to update my website? And I didn't know about administrator panels because I was 12. And what I came up with was this concept that, well, I know that in my site I'm querying a database, and if I change the parameter to a URL, I'd be able to secretly access the rest of the database and be able to update the content on my site. I was very proud about this. I thought that this was something only I thought of. And it turns out that's called SQL injection. So very famously, xkcd 327 little Bobby tables. the punchline is that she named her kid with an SQL injection to exploit various systems. Another example that I really like is from 2012 when Homakov had the Rails mass assignment vulnerability. What's interesting is that he knew that GitHub used Rails, and he knew this vulnerability was in Rails, and the Rails maintainers were not taking his report very seriously. So what he decided to do was forge a commit and change the keys out on GitHub, and then just force push a fix to Rails on GitHub because that's where it was hosted. So, I mean, he solved the problem himself very efficiently. Most attackers are not that polite. So here's how a mass assignment vulnerability works. At the top, we have a form. This is the form that the browser would be submitting. Note that there's only like a username and a password, and then you submit it. And then in the middle of the screen, you see the model that the web server has implemented. These are the variables that they expect. You'll notice that one of them is whether or not the user is an administrator. And then you'll notice at the bottom of the screen, this is where the web request actually gets received and processed. And if you'll notice, it just automatically adds everything that the user submitted into the database. And the problem with this is that they can just set, I am an administrator, and suddenly they have administrator access on your website. Another example, this one has actually caused a lot of problem in the land of Bitcoin, and also apparently Monero, because Monero had a user-hosted web server wallet called Simple Wallet that had HTTP JSON RPC access, and unfortunately it had no cross-site request forgery protection. So when you browse the internet in your regular browser and you had Simple Wallet running, other websites could just drain all your funds. So cross-site request forgery protection is really important. So I was talking with a friend of mine a while back, colleague, and we were talking about Mt. Gox. And he was saying, yeah, I seem to recall that was just a website that I could just break into pretty easily, just walk in and take whatever I wanted. And you know, sometimes in the security industry, people tend to boast a bit and inflate what they've accomplished and what they've done. But for Mt. Gox, we actually do have Mt. Gox source code floating around out there, and we do have a Mt. Gox database floating around out there. So it's actually conceivable that he might not be lying. It's very possible that Mt. Gox was hacked. Yeah. But it could also be an exit scam. Who knows? There was also the alleged infiltration of cryptC. This one was fun. So again, I mean, most of these, you know, exit scam or where they hacked, who knows? But allegedly, the way that this worked for cryptC was they were a Bitcoin exchange that also ran a bunch of altcoins, altcoin nodes on the same server, like all on the same server. There was no separation. And the story is that they installed an altcoin that just had a backdoor, and the creator of the altcoin just like SSH'd in or something, and it was like running an SSH server or even an unprotected backdoor. So that actually sounds really plausible. I'm willing to say cryptC was probably hacked, and it was also an exit scam. Another interesting one for web application security was the Bitfinex heist in 2016. This was actually a bit contested because it was like he said, she said, like they claimed BitGo screwed up, BitGo claimed they screwed up. BitGo was presumably providing a service to monitor and modulate the total amount of Bitcoin that could be withdrawn in a single day. And allegedly, what the attacker did was just turn that off, and then they could just take everything. So that sounds like they were hacked. Another interesting one that wasn't an exchange, but it applies to exchanges, is the Doge wallet, and this was a Christmas hack. And anyway, what the attacker did was they noticed that users would go to the website and deposit coins to an address, and so the attacker said, well, why not just change the address to my address? And they did, and they got a lot of money. So that was hacked. I'm wondering if there's any lessons we can learn from this about Bitcoin exchanges and websites in general. I'm afraid that the answer is no, we can't learn anything because people will continue to use websites and the internet. But yeah, don't use exchanges. So there was an interesting case of on Node. They have a package manager called npm LeftPad was a very popular package in Node that only had like a few lines of source code, but everything in the Node ecosystem depended on this package in the npm repository. So anyway, the maintainer rage quit and removed it, and then the whole web broke. And the reason I bring this up is because it's a case where in the ensuing chaos, there is a tremendous likelihood that someone will release an alternative or a replacement that is actually malicious. And you need to be careful in these times of chaos to not fall for fake alternatives that are malicious alternatives. And the reason I bring that up is because it's a prelude to the next fun one, which was targeted to the Bitpay Copay wallet. What happened was that a maintainer of a library on NPM decided that he no longer wanted to maintain the event stream library, and he gave ownership of that repository and project to another user who turned out to be malicious and added something called flatmap stream, which had encrypted malicious code that only became active in the Bitpay incident. This was a pretty serious problem because this could easily steal Bitcoin. What's interesting about malware is that there's actually a lot of really clever ways to do it. One of my favorites is not related to this incident, but sometimes what malware authors do is they write malware that's encrypted by the values of certain environment variables you expect to have on your target computers. And so only if you know what the actual target is will you be able to decrypt that software. Environment variables can have all sorts of values, so you can get very specific. Interestingly, Bcoin removed all external JavaScript dependencies as a response to the flatmap stream incident. And so that's an interesting way to deal with it. But really what you should do is you should pin all of your dependencies to a certain version number and also a hash. Just a version number isn't enough because someone can force push a new version of that package with the same version number. So you should always do a hash-based pegging of your dependencies in a web application. So a fun one that people overlook often is information disclosure vulnerabilities. This one is quite simple, but do not tell users things that they shouldn't know. Like the most common case is getting an HTTP 403 forbidden error when you should be getting a 404 not found. If you know it's not found, then you know it's there, even if you're forbidden from accessing it, and this can leak a lot of data. So don't do it. I've also noticed that a lot of companies that run web applications have insufficient logging. If you just happen to log into any of their servers, they often don't know. So that really needs to be fixed. And like they don't have AppArmor profiles or other things configured. You can just like go in and no one knows. I mean, it's a pretty big problem. People should really work on that one. Also, Bitcoin companies, if you store Bitcoin on behalf of anyone, or even your own Bitcoin, you should always be monitoring it with a watch-only wallet that is separated from how you securely store your Bitcoin. Not many people actually do this, especially companies, but it's so trivial to just run some other servers in a closet somewhere that regularly monitor the Bitcoin network. You should be notified within seconds of any transaction broadcasted related to your coins, and many companies aren't notified of that. There's a lot of other incidents. An interesting one was a problem in Safari 6 using the JavaScript just-in-time compiler. It turned out that in certain situations, Bitcoin wallets were being generated using some particular software in a way where you can only spend your coins in the future if you are using the exact same version of the browser. Because in future versions of the browser, the way that the just-in-time compiler for JavaScript worked removed certain code paths and execution paths that would cause you to not be able to sign for your coins. So that was actually kind of hard to track down. There's been cases of people using incorrect random number generator sources, like they think they have a source for random numbers, but it's not random. An interesting one was a Bitcoin wallet that used https://random.org for their random numbers. That's really stupid. Don't do that. Oh, and also like social engineering attacks. You can just go ask a data server, hey, can I get access to a server? And sometimes they say yes. So that's really bad. Another bad one is browser extensions. You should be really careful about how many browser extensions you install, especially if you do anything related to Bitcoin. Like obviously you should not have your private keys on a computer accessing the internet, but even if you're doing like non-private key related things like watch onlys or something, be mindful that browser extensions can have malware that monitor and detect your use of your browser and the internet, anything you do with Bitcoin, including looking up addresses on block explorers. That's a huge privacy leak, and all sorts of extensions are like selling data to like the surveillance companies that were previously mentioned. One of the biggest problems, though, is called account recovery. This goes through, on every website, if you forget your password, you have a way for users to request an ability to get back into their account. Sometimes that's based off of secret questions, like the year you were born or something, which is not secret. But also they have usually SMS recovery, which is really bad because an attack called SIM porting allows people to just go into any telecom store, claim they're you, and get access to your phone number and then be able to reset all your passwords. So if possible, try not to have a phone number. That's one protection. Ideally, use multi-factor authentication on websites that provide it, and be very suspicious of a website that allows for password recovery or account recovery through a phone number, like phone calls or text messaging. One attack I remember seeing is that there have been cases where attackers just go on a website and disable the multi-factor authentication without requiring multi-factor authentication. So if someone can just click to turn it off, then it provides absolutely no security anyway. So don't implement that. There's recently an interesting standard supporting hardware keys for websites. Better than Authy, in my opinion, because those can be broken through pretty trivial means. Interestingly, after Google implemented this, none of their 85,000 employees had any sort of phishing attacks successfully succeed since implementing hardware keys. So it's good evidence that this might actually work. Gemini has implemented it, and interestingly, as I was doing my slides, Coinbase implemented it. So on a totally unrelated note, due to unforeseen circumstances, my live hacking demo has been canceled. I want to talk about responsible disclosure for a moment. You should be mindful of vulnerabilities that you're reporting and how you report them, and try to be responsible for them somehow. That means notifying vendors ahead of time before you release information to the public. Look for companies that offer bug bounty programs, and maybe if you're poking around at websites, just focus on those websites that have bug bounty programs. There's also an issue with responsible disclosure that I want to bring up about Bitcoin Core itself, which isn't a web application, but many people don't think about this, especially in the altcoin community, which is that if Bitcoin Core figures out a vulnerability and fixes it, perhaps silently, so as to not alert attackers on the network to go and do this thing, note that altcoins that are direct forks of Bitcoin Core aren't necessarily informed about these vulnerabilities, because there are so many thousands of these forks that it is actually insecure to disseminate information about security vulnerabilities to everyone, because in some cases, these people are like actively hostile to Bitcoin. So if you are a fork or derivative of Bitcoin Core, your security story is really weak and flimsy, because you're not going to hear about all the security issues that you have. So other than just doing illegal things and hacking websites, how do you get really good? Well, in my opinion, the way to do that is actually through gaming, not through hacking websites. Gaming provides a fun environment for doing this. In particular, there's this whole community online around speedrunning, and what they do is they look on YouTube for people who are doing glitch hunting, and then they like cannibalize the glitches to make shorter routes in speedrunning. And anyway, there's this whole ecosystem that's developed around it. And some videos at the bottom of the screen show this off, including the last one is actually a race that was done on the Pokemon Blue RPG game between two players that were blindfolded and were using glitches the whole time. And they were able to win the race within 30 minutes or something. Yeah. I don't know if anyone remembers, but there used to be this hacking device sold to children in the 90s for Nintendo, a Game Boy and Nintendo 64. It was called a Game Shark, and what it allowed you to do was modify values in memory to like set infinite health or infinite bullets and whatever else. You know, looking back, it's actually kind of surprising that they allowed children to get access to like authentic hacking equipment. That was cool. Another way is reverse engineering, though. The reason I brought up the Pokemon game was because one of my projects I did a while back was a reverse engineering of the original Pokemon games back into source code. And the way that I know it's correct is because it compiles back into the same ROM, byte for byte. So this is an interesting way to develop skills for breaking into things and seeing how things are built. And it's now actually the second largest reverse engineering project in video games behind Sonic, strangely enough. Sonic has a well-organized community around reverse engineering for some reason. So you should disable JavaScript. That's probably like the only takeaway I really care about here. Just disable JavaScript. Like, do it right now. Like, I see a lot of you. You have your laptops open, disable JavaScript. Don't install browser extensions. Don't install browsers. Also remember, if you don't have the keys, they're not your coins. Don't use exchanges. Yeah, just disable JavaScript, please. All right, that's it. Thank you. Unless I'm told otherwise, I believe I have time for a few questions. Oh, right. So there was, Warren has reminded me that there was a new proposal on GitHub for, it's actually two different things. One was that there was a proposal for a standard called security.markdown for GitHub repositories for standard reporting of vulnerability disclosures and things like that. And I think GitHub has recently formalized something similar to that. I don't think it was security.md. I think it was another one. But that was interesting. Any questions? Ask me if your favorite website is secure.
I can just shout maybe. How about that, like, development of Bitcoin still happens mainly on GitHub?
You're asking why does development of Bitcoin still happen on GitHub?
It's a very centralized resource in that sense where the source code is hosted. I mean,
well, it's actually not that big of a problem that the source code is developed on GitHub because Git is already a decentralized tool. And in the event that GitHub goes away, all of the Bitcoin Core developers already have Git repositories. And in some cases, they already mirror it on other public websites anyway.
Yeah, I remember following the event stream incident. And one part of that that you didn't mention was that the malicious code was only present in the minified version that Node by default pulls from NPM.
So I actually didn't know that, so that's interesting. So the idea was actually you don't put the malicious code in the source code that other people could download, but rather in the minified code, which is very difficult to read. I actually once wrote a deobfuscation tool for JavaScript that replaced all the hidden, condensed variable names with like food items. Anyway, it makes reading obfuscated code a bit easier. So anyway, the lesson from that would be don't use cached CDN JavaScript libraries either. And that's actually really popular. Like even the jQuery website recommends you just copy and paste a CDN link into your web page to use jQuery. So you shouldn't do that. Well, blockchain.info has always had vulnerabilities and problems. Okay, I think that's it. Thank you.